All right, I'm going to do another example. Same thing. We're going to focus on the p-value. In the previous video, um, I did an example just kind of going to more value is. And so we'll do a similar example here and just see exactly what we mean by p-value. So, local politician claims that his legislation has resulted in fewer property taxes for county residents. Previously, the average household paid $8,700 per year in property taxes. A recent survey of 50 residents showed a mean tax amount of $8,350 with a standard deviation of $1,800. At alpha equals 0.05, is there evidence to support the senator's claim? Okay, so this has a few differences than the last one. Um, First of all, let's look at the hypotheses. Okay, fewer property taxes. All right, well, so let's think about what our null and alternate hypotheses are going to be. Well, previously the average household paid 8,700. So we're going to claim that the taxes are lower. But by default, we have to assume, okay, the taxes are still 8,700, and we're trying to show that they went down. So again, I'm going to find my test value. Now, so the first difference between this last example and the current one is now we have a left tail test because fewer. That's the key right there. In the previous example, it was just it said different. Now we're saying fewer. So that's the first difference. Now the second difference is right here. A recent survey of 60 residents showed a mean tax with a standard deviation of 1,800. That's a sample standard deviation. Whereas in the previous example, we saw a population standard deviation. So this is S, not sigma. So because of that, I need to use the t-distribution. There's not going to be a huge difference in calculating, but it's going to make a difference in how we look up our areas and how we look up our p-values. So again, I'm going to take the sample 8,350 minus the hypothesized population mean of 8,700, and again, I'm going to divide by 1,800 over square root, and what was it, 50? Okay. And let's figure out this t-score. So we have negative 1.37. Okay, we have negative 1.37. So again, we're going to think about, okay, how do we get the t-score from that? And it's the p-value, rather. How do we get the p-value? Well, the p-value, again, is the probability of getting a value less than, because it's a left tail test, what's the probability of getting a value of less than 8,350, assuming that the null hypothesis of 8,700 is true? So I'm just going to erase a little bit, so I need to make a little bit of room here. It was negative 1.37. Okay. So I'm going to do the same thing we did before. I'm going to make a well, it's not a normal distribution anymore, it's a t-distribution, but it's still bell-shaped. And let's say, okay, we have our original x values of, so we assume 8,700 by default, which is a z-score of 0, and negative 1.37 was the z-score we got was the z-score we got. From 8350. So again, what are we trying to figure out here? Well, what is the probability of getting a value less than 8350? If the null hypothesis is true, and indeed the taxes haven't gone down, well, what's the probability of getting something less than 8350? Oh, there we go. So yeah, what is the probability of getting something less than 8350, assuming that 8700 is the true population mean? So I need to find this probability of having I should say a t-value. That is a t-score, not a z-score. Yes, okay, what is the probability of getting that t-score of less than negative 1.37? Okay, so this is going to be a little trickier to look up than for the z-score, because the z-score, we could look in the z-score table and get an area that matches the z-score that we got. Now, the t-table works a little bit differently than that. I cannot directly look up any particular t-score. So what I'm going to have to do is this. We have 50 residents, which indicates 49 degrees freedom. So, which happens to be right at the bottom. So I think we can zoom in here. 49 degrees freedom. It's positive numbers here, but 1.37. Because realize a t-score is still symmetric, and therefore the probability of getting a score less than negative 1.37 is the same thing as getting a score of greater than positive 1.37. So what I'm going to do is I'm going to look here, 49 degrees freedom. I see that 1.37 would come between these two columns. And what are these two columns? 0.10 and 0.05. Between 0.10 and between 0.05. So that's where my p-value is going to lie. It's between the 0.10 and 0.05 columns, so I can estimate that my p-value is between 0.05 and 0.10. So, and again, I'm not going to double that here because we're looking at just the area in the slab. So this area, that's what this area is, somewhere between 0.05 and 0.10. So what does that mean in terms of whether or not we reject our null hypothesis? Well, our alpha value is 0.05. And so no matter what, our p-value is going to be greater than alpha. Because it's somewhere between 0.05 and 0.10. Well, it might as well be between 0.05 and 0.30 for all we know. We know it's above 0.05. And because it's above 0.05, we only reject the null hypothesis if the p-value is less than alpha, and that's not the case here. It's greater than alpha. So in this case, we do not reject. And again, I don't have, well, okay. So we have no evidence to show that taxes have decreased. Because that's not we have too big a chance of making a type 1 error, and so we would fail to reject. Because again, the p-value in this case is, the actual meaning is, if the null hypothesis is 8,700. We have between a 0.05 and 0.10 probability of getting the result that we got, the 8,350. That's not strong enough evidence. That's not below 0.05, so we don't have enough evidence to reject this null hypothesis. So hopefully this gave you a little bit of insight into what a p-value is and what it means.